So last class we discussed about bearing material important properties. Today's class we are going to discuss some of the important material which we are using for manufacturing of bearing materials. Yes, it's a one important material called babettes. It is also called as white metal. So first important a bearing material called babette metals, or it is also called as a white metal because they are appears like a silvery color. That's why it is called as a white metal. Then why the name is called a babette metals? In 1839, Sir Isaac Babbitt obtained a patent. Means he is the first who discovered this material. Means for the bearing, he first discovered this material, and for his discovery they named it as babette metals. Okay, so it is appears like a silvery color, that's why it is called as white metal. Then why it is babette metals means because this metal is discovered by Isaac Babbitt. That's why this metal is called as babette metal. And this babette metal mainly contain a tin. It's an alloy, of course it is a alloy. Alloy means combination of two or more metal in microscopic level, not in the macroscopic. If it is macroscopic, then it is called as a composite material. They are in the microscopic level, that's why it is called as alloys. A combination of two or more metals combined in microscopic level, means one metal is dissolved in the another metal, that's why it is called as a alloys. Okay, here these babette metals are also a alloys, and these metals contain mainly a tin as a major constituent. Okay, tin, along with the tin, antimony, copper and lead. Antimony, copper and lead are the minor constituents, and the major constituent is tin, and these combinedly it is become a alloy, and that alloy is in silvery color, that's why it is called as a white metal, or it is discovered by a Sir Babbitt, that's why it is named as babette metals. Okay, and these babette metals again classified or grouped in two categories. One is a tin based babette. The first one is a tin based babette, and second one is a lead based babette. If the major constituent is tin, then it is called as a tin based babette. If the major constituent is lead, then it is called as a lead based babette. And these two are entirely different and different applications. Okay, even though they are babettes, because both are discovered by a babette, but first one is it's a tin based, second one is a lead based. We'll go to the first one. The first one is a tin based babette or tin based white metal, and this material that contains a more than 80%. It contains a more than 80% of tin alloy. It contains more than 80% of tin alloy, that's why it is called as tin based. And this tin based babette is free from the lead. Here there is no lead. Okay, it's a free from lead, only it contains major constituent is more than 80% tin alloy. Along with this, it also contains some part of antimony. It is also a metal, we already know that antimony is a metal, and copper. Okay, lead. If you find some tin based babette that completely a lead free. Okay, here there is no lead, and these are mainly used for the machine parts. Okay, because here it is having a more load carrying capacity. These are very hard metal. These tin based babettes are hard metal, that's why they are used for more load carrying capacity in the first property. Okay, it's a load carrying capacity, it used for a more load carrying capacity. Okay, come to the properties, some of the properties of This babettes are it provides a low wear as well as low friction of resistance because it is having a high load carrying capacity. If the high load carrying capacity, indirectly it is a hard metal. If it is a hard metal, the wear rate is wear rate obviously reduces. If it is a soft metal, wear rate is more. The wear resistance is less, but here wear resistance is more because it is a hard metal. If it is a hard metal, it is used for more load carrying capacity. Indirectly, the wear rate is less. What is meant by wear? Wear means a loss of material with respect to the time. A periodic loss of material is called wear. Okay. So here wear rate is less. Wear rate less means it is having a high wear resistance property. Clear? Because it is a hard metal. And the flows well when under pressure. Okay. So when under pressure, it is the flow rate is having a moderate flow rate, and which is ideal for used machineries where there may be a inadequate lubrication along with bearing and shaft that are operating at high speed. Where the shaft at our high speed, okay. So here it is having a self lubricating. This material itself having a self lubricating, and where a small amount of lubrication is possible. In that situation, we can use this type of tin based babettes, okay, as a bearing material. And it can also absorb dirt particles or foreign particles or contamination. That is what it is having a more embeddability. It is having a more embeddability means we already discussed what is meant by embeddability. It absorbs the dust particles or contaminations in the lubricant so that it will avoid the seizing of materials. Okay. So it is having a good embeddability property, and it is having a high thermal. It is having a high thermal conductivity so that it will carry the heat from one point to another point. It is having a high thermal conductivity as well as low thermal expansion. Low thermal expansion and high heat carrying capacity. That's why it is used in the machine parts. Along with this, it is also used in see here in the compressor. It is used in the compressor where we get a high pressure air or a fluid, and electric motors, heavy machineries and marine works. So where there is a heavy load is there, in that we are using this type of material because it is used for heavy load carrying capabilities. Is it clear? Okay. So this is a one type of a bearing material. It is a babette, in that it is a tin based babette. Clear? So in the examination, if you ask, first you have to write what is meant by tin based babette, and you have to explain the characteristics, and afterwards you have to explain where there is used application. You have to write the properties and you have to write the applications. Okay. So next one is lead based babette. In that it is also a babette because it is also discovered by a Isaac Babbitt. That's why it is called as a babette. It is a second type, means lead based babette. It's another common bearing material, as it will contain 75% of or more lead alloy. So this material is purely lead based alloy. The first one is purely based on tin alloy. Okay, it is called as a lead alloy. It is contain a lead alloy. Along with that, it is also contain some amount of antimony, copper, etc. Okay, so antimony, copper, and other materials, they are used to just to enhance the properties of this lead alloy. just to increase the lead alloy property, we are going to add some amount of other materials like copper and antimony. Okay, this itself a lead. So lead, we already know that lead is a self lubricating metal. When compared to steel, copper and others, lead is a self lubricating. Okay, it no need to another lubrication process. Clear? It's itself a producing a self lubricating. Clear? And of course it is not hard when compared to the previous one. So previous one is, it's a very hard material, that's why it is used for heavy load carrying capacity. When compared to tin based, it is a soft material. And this material has an excellent corrosion resistance. It is having an excellent corrosion resistance, which makes ideal for shipboard applications and other work where there will be a high humidity or moisture. Means where the material or bearing exposed to the moisture or humidity, in that cases we are going with this type of babbits, because previous one is, it is for heavy load. Okay, but in the previous one, if it is exposed to the humidity or moisture, the corrosion resistance is very less in case of tin alloy. But here in case of lead based alloy, it is having a high corrosion resistance property. Okay, if it is a high corrosion resistance property, this materials can easily used in the where the moisture is more or humidity is more. Why? Because moisture and humidity causes the corrosion in the metals. Correct? But this metal is having a very high corrosion resistance, so that we can easily used in those situations. It is also provided, just like a tin based, it is also provide a frictional capabilities, having a coefficient of friction is very less in this case, and adhere to the well both bronze and steel. And it is also can having an wear well, and it is used in the machineries where it provides the long life. And some of the important properties is with a good embeddability and high thermal conductivity and great conformability. So these properties are very good in this case, lead based, and it is preferred for the low and medium speed. Previous one is preferred for high speed, but this one is preferred for low or medium speed machineries, because the load carrying capacity is slightly less when compared to previous one. And of course it's an very economical when compared to the previous one. That's why it is used in the machineries, a lining shop and machine shops, and it is also used for form machineries, cement machineries, conveyors, elevators, and these applications we can use this type of babbits as a bearing material, not as a major material. It is used as a bearing material. Clear? So previous one is tin based babbit, and second one is lead based babbit. So this babbit means they are basically alloys, and it is discovered by babbit, and they are look like a white or silvery color. That's why it is also called as a white metals. It's clear? Yes. Second, so now we are discussing about only a pure metal based bearing materials. Only we are discussing metal based bearing materials, and in the next class we will discuss a non-metal bearing materials. So in this class we are going to discuss only a metal based bearing materials. In that, a second important bearing material is aluminium alloys. We already know that what is meant by aluminium. Aluminium is a metal. Okay, it is a second abundant material available on the earth crust, next to that is what, ferrous, next to the ferrous. Okay, next to the ferrous metal, second abundant material available on the earth crust is aluminium. Okay, when compared to the copper and other metals, it is very economical because it is a freely available. The availability is very high. So availability is also one important property we already discussed in the previous class, and also cost is also another property. Yes, it is well suited for this. It's a aluminium alloy. So aluminium alloy, we already know that it's having an n number of alloys. Mainly they are categorized a wrought aluminium alloy and cast aluminium alloy. Gottidiyala? The aluminium we already discussed in the material science what is meant by aluminium and what are its alloys. So aluminium alloys are categorized wrought aluminium alloy and cast aluminium alloy. The series is there. Example AL 2024, AL 7071, like this. Have you heard? Huh? Kelidira? AL 2024, okay, 6061, 7073, like this. 2, 3, 4, 5, 6, 7. It's a series. Okay, means that that means it is having an, along with the aluminium, some other metals they are going to add. If it is a 2 series, means along with the aluminium we are going to add copper. If it is a 6, copper, like a copper, another metals is added, ferrous is added. Okay, along next tin is added, lead is added. Okay, like this. If we add another materials to the aluminium, then it is become a some other series of alloys. Clear? So that aluminium alloys is also used for our bearing materials. Aluminium is the major constituent. If it is a pure aluminium, means 99.99% aluminium is there. Of course, it is having an advantages, but along with that there is a drawback. What is the drawback of aluminium? What is the drawback of aluminium? It's a lightweight. It can't use for the heavy load applications if it is a pure aluminium. Okay, and advantage is it's a corrosion resistance. Aluminium won't get corrosion. Okay, but the yes, low cost and density is very less, lightweight. But if the density is less, what happens? Of course, it is a ductile material. It is not a brittle material. But pure aluminium is a brittle one. But wear resistance is where it is less or more? Very high. Wear rate is very high because it is a soft metal. When compared to steel, steel wear rate is less, but aluminium wear rate is more. It will easily wear off. Okay, so this is a drawback. To avoid this drawback, we are going to add some other materials to the aluminium, and it is become a alloy. So alloy having a better property when compared to the pure aluminium. So here we are using aluminium alloy. Okay, and these aluminium alloy exhibit a very good properties. Okay, the first property is it is a good fatigue strength. We already discussed fatigue strength is also one property of a material or bearing material. Here it is having a very good fatigue strength. That's why this aluminium alloy used in the IC engines. IC engine, that connecting rod, okay, it is made by this aluminium alloys. So having a good fatigue strength, a load bearing capacity, a thermal conductivity and corrosion resistance. So these are the good properties of aluminium alloy. A load bearing capacity is also high, and thermal conductivity, of course aluminium will conduct the heat, so thermal conductivity is more, and obviously basically it is a corrosion resistant material. And less expensive. They are less expensive because easily available. So when compared to the Babbitt metals, it's a less expensive. When compared to the previous one, it's a less expensive. And most aluminium alloy contain element which remains a free state. It is better for bearing surfaces. Means the density is very less. Aluminium alloys, when compared to the previous one, density is very less. That's why it is used in the bearing material. And the strongest aluminium alloy is aluminium silicon. In all these alloys, okay, there is a n number of aluminium alloys. In that, strongest aluminium alloy is which one? Aluminium silica, because we already know that silica is a very hard metal when it is contact with when it is combined with any metals, it is become a hard. So it is a hard means obviously it will increase its strength. So it is a strongest aluminium alloy. Where we need a high load carrying capacity, in that we are using aluminium silica as a bearing material. So thermal expansion is relatively high when compared to previous one or compared to the steel and other. The thermal expansion is obviously high because it will conduct more heat. So if it is a more conductivity, it is also having a more expansion, thermal expansion. But actually what we want, the thermal expansion should be less or more? Should be less, correct? The thermal expansion should be less, but here it is a drawback. That's why it restricts its application in high temperatures. If it is exposed to the high temperature, obviously it will increase the thermal expansion. Okay. And of course, these are the another important properties: good humidity, comfortability, okay, and compactability are not good when compared to the previous one, but they are moderate when compared to the other metals. It is a moderate. Clear? This is the aluminium alloy. It's the next important bearing materials in metals. So after that, next important metal bearing materials are cadmium. Have you heard cadmium? It's a one important metal, and silver. We already know that we can use silver and gold as a bearing materials, but why these are restricted? Because of their cost. Okay. So here cadmium, it's a cadmium alloy also we can use for bearing materials. Cadmium alloy offer a good fatigue resistance and excellent compactability properties. Okay. Good fatigue resistance means it can expose to the cyclic load. A fatigue means it's a cyclic load, and these type of alloys we can easily use for where the cyclic load is there. And also excellent compactability. Okay, it won't seizes or it won't weld on the other surface easily. That is the compactability. And corrosion resistance is poor when compared to the previous one, aluminum alloy. Cadmium alloy is having a poor corrosion resistance. If they are poor corrosion resistance, what happens? We cannot use in the moisture or humidity conditions. Clear? And they are expensive. Previous one, aluminum alloys are the less expensive, but these cadmium alloys are expensive. Clear? So that these applications are very restricted. They are not easily used because their application restricted because of the corrosion resistance property as well as a poor corrosion resistance, and they are expensive. Clear? Of course, even silver is also expensive when compared to the aluminium. Is it correct? What is the cost of aluminium 1 kg? Generally, cost of aluminium? Okay, 500. Let us assume a good quality of aluminium is 500. But what is the good quality of silver? Yes, it is near 40,000 nearly. What's the cost of cadmium? It may be 3 or 4,000. So like this. Okay. So cost is also very high. And another metal is silver. So silver, we already know that these silvers are not directly used as a primary metals, bearing materials. They are not used directly as a primary metals. They are used in the deposits. Deposits means coating. One primary materials is coated by this silver alloys. Okay. It's just like a bimetals. It is used as a deposit materials on the steel. Means on the steel we are going to coat on this silver. Why? Because silver is a costly. If you use as a primary means it cost increases. Okay, that's why it is used as a coated or deposited on the steel. The deposit may be in terms of microns, 10 microns, 20 microns, 30 microns, means very, very thin layer. And in addition of lead improves the, means this silver along with lead, if you add lead as a additive in the silver, it will improve the properties of silver. Okay, those properties are embeddability, anti-weld, anti-scoring properties. Anti-scoring means, or anti-welding means embeddability. Okay, it will increase the embeddability. By adding lead, it will increase the embeddability, compactability properties. Clear? Anti-scoring means, or anti-seizing. Scoring or seizing means when it is contact with another surfaces, if there is any particles, it will seize the motion or it will seize the process. It will stuck. That is called anti-scoring or anti-seizing. Okay. Next materials are next important materials are multi-layered bearings. This is called multi-layered bearings. Means there is a primary metal. On that metal we are going to coat some other metals. It is called multi-layer. If go with a single layer, if go with a double layer or triple layer, if you increase the thickness, it is become a 3 layers, 4 layers. Okay. If the thickness is very less, it is become a single layer. It is also called as a bimetals. So it is also called as a bimetals. Means have you heard this bimetals? Bimetals. What is the difference between bimetals and the alloys? Bimetals. Alloys are absolutely they are soluble with other metals. Okay, one metal is soluble with another metals in microscopic level. But bimetals means bimetals. The two metals are joined. Okay, if the two metals are joined, it is become a bi. Bi means two. Okay, more than one or two. Okay, so bi. If the two metals are joined, it is become a bimetals. Okay, here we cannot use any additives or we cannot use any your epoxies or resins to join the two metals. Of course, joining is it's a process. Okay, either you can use the welding, brazing, soldering. Also, we can join the two metals. If I join two workpieces with the help of weld, can we call it as a bimetals? Can we call welding? With the help of welding, I am going to join the two metals. Is it called as a bimetals? Adhengagutte bimetals. Al welding ondidaltane, it is become a trimetals. So bimetals means without using any other, okay, any other third substance going to join. Without using any third substance, the two metals are joined. That is called bimetals. So how we can achieve this? That is by depositing. Kelidra, depositing. One metal is going to deposit on the other metals. So like your wall. So in wall is it. So wall again marti now. We are going to first wall irutte. Paint martidane. So one layer of paint, second layer of paint. Correct? What is the purpose of painting? What is the purpose of painting? Of course, first one is aesthetic look. When compared to the raw wall, aesthetic look improves. Correct? But apart from that, yes, it will protect from the moisture. Okay, the paint is protect from the moisture, okay, or sun rays or any other thing. Okay, the wall is protected by paint. Same concept we are using here. One primary metal like a wall, and like a paint we are going to coat the other metals. So this coating material will provide the necessary properties of bearing. Clear? That coated material provides the necessary important properties of bearing material. If I use steel, okay, I used steel as a bearing material, but steel is having a lot of drawbacks. It is a less corrosion resistance, correct? It's a less corrosion resistance, less embeddability, okay? All these are drawbacks. Just to overcome those drawbacks, we are going to coat some materials over on that steel or primary metals, and that is called multi-layer bearings. So overall the cost, why we have to use this process means just to reduce the cost, because another costly material is just going to deposit. Okay, the primary metal is having a less cost and it provides some strength. Ultimately the overall cost is less. ಈಗ ಸಿಲ್ವರ್ ಇದೆ, ಸಿಲ್ವರ್ನೇ ಓವರ್ ಆಲ್ ಮಟೀರಿಯಲ್ ಆಗಿ ಯೂಸ್ ಮಾಡ್ಬೋದಿತ್ತು ನಾವು, ಬಟ್ ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ ಕಾಸ್ಟ್ ಇನ್ಕ್ರೀಸಸ್. It may the bearing may 0.5 kg means the cost is become more than 15 to 20,000. But the silver is coated on the cast iron or steel. What happens? The overall cost may reduce to 500 or 1000. Clear? So this is a multi-layered bearing. Here steel is normally used as a backing or primary metal. Backing anta karitive, or else it is also called as a primary metal. And here just to why? Just to enhance the properties. Why you have to use this process means to enhance the properties of backing material. Okay, like embeddability, whatever the properties we discussed, those properties are we can increased. How? By coating one material on a backing material. And here of course we can use a plain bearing with a multi-layered bearing. If it is used a single layer, it's a single layer bearing. Multi-layer means a double layer, or even this layer is again depends the thickness. If more thickness, it is a multi-layer, means single layer, double layer, triple layer, like this. If the thickness is less, it's a single layer. If the thickness is more, 800 microns, means it is a tri-layer. Okay, like this we are going to categorize. If more deposition means again it will cost the more. And of course here Babbitt's is also used for this multi-layered bearings by coating some other. And the wall thickness of backing materials is bimetals. If it is bimetal, the thickness 0.3 times the bore with a minimum value of 1.5 mm. It's a bimetal. If it is called as a bimetal, the thickness is 1.5 mm. If it is trimetal bearing, the surface layer thickness could be low as 25 microns. 25 microns. With increase in the Babbitt thickness, the overall fatigue strength decreases. If you increase the thickness of this layer, it will decrease the fatigue strength. Okay. So these are the some metal based bearing materials. Okay. So which are those? The first one is Babbitt metals. Second one is Babbitt in that lead based and tin based, and the next one is aluminum alloys and cadmium and silver alloys and multi-layered bearings. Okay. And in the next class we will discuss non-metallic bearing materials.